So what we need to make sure we understand here is this. When making any type of graph, no matter what the graph looks like, picture graph, pie chart, bar chart, any type of graph, it is important to avoid adding embellishments that are potentially misleading. Meaning, don't add extra stuff that don't exaggerate things. All right? Don't add things that are going to be potentially misleading. All right? The first type of way you can be misleading is to violate the area principle. You don't want to do that. Okay? And what that means is, that means the area representing each category in a graph should be proportional to the number of observations in that category. All right? So again, the area representing each category in a graph should be in proportion to the number of observations in that category. Okay? So what that means is, if we're looking at this graph, okay, the area that's representing a certain occurrence, one shouldn't be like a lot, like right here, those 4 baseballs take up a lot more space than the 3 footballs. All right? And even looking at the 3, if you just look at 3 baseballs, the 3 baseballs take up a lot more space than the 3 footballs. So this graph, if we were to think of this as sort of like a horizontal picture chart, 3 people choosing football, 4 people choosing baseball, you have your graph. Right? The issue here is that the footballs don't take up the same amount of space as the baseballs. So it sort of misguides you, it misleads you to think maybe the baseball, like maybe more people chose baseball because that area is bigger. All right? Whereas in reality, only one more person chose baseball over football. All right? But since there's so much more area taken up by the baseballs, it may cause someone to believe baseball is a lot more popular than football, which is doubtful. All right? So that is the area principle. Now, the next thing is, so I have it written down? Yes, no, maybe. Yeah. Here's another type of misleading type of graph. All right? Making a pie chart or bar chart look 3D. Don't do it. Okay, you have that option on computers. Don't make a pie chart or bar chart look 3D. Okay? Ron's looking at me like I'm crazy, like, why not? It looks cool. Well, think about this. If this little extra piece right here on the side, it makes this look like it's more than what it really is. It makes this look like it's more than 75% of this graph. Because all you can see, you can see all this edge colored in orange, but you can't see that height of this graph in yellow in the background. All right, so what it makes it do is it makes it appear. It's not actually, but it makes it appear that the orange is more orange than what it really is. All right, it makes the percentage of orange look greater than what it really is. Okay, so here's it. You guys are going to have to make graphs. Okay? Don't make your graphs 3D. That does not help you. All right? It looks cool, but it's not cool. So, another type of graph. Now, this is a very important one. Because on the other class, we could have docked some points on this, but we didn't because we were being nice. Making the percentage axis, the y-axis, on a bar graph not start at 0 or making the percentage scale inconsistent. Notice, this scale starts at 25 instead of 0. Alright? These are the percentages of LeBron James' shooting percentage. Alright? So, this right here where LeBron James made like 31.7 or whatever it was, and or 31.5, and where he made 25.7, it looks like he almost made no shots in the playoffs. It looks like you would think if you look at this, oh, he shot 0%. Oh wait, I didn't really look at this. It says 25% all the way down here, so he shot 25%. This, you don't want to start your scale at anything but 0. You should always start your scale at 0. Okay? The one exception where you don't start your scale at 0 is if you're making a graph and you put a break in the graph, and you might start at 25. But even then, in this case, 25 is still up where 25 should be, not down where 0 should be. That make sense? And to make the percentage scale inconsistent, that means that you start at 0, go 25, 40, 45, 50, 55, 70, 80, 100. Where you jump around, where these numbers aren't evenly spaced out. Alright? I believe that's the last one. You guys didn't like the sound, did you? Yeah. This is enough for it. Okay? So each of those types of graphs, they can all be misleading. Okay, they can all be misleading. And what you need to do is you need to avoid the temptation to look stylish and pretty. Don't write about this. This is just me telling you don't be fancy. Alright? Keep your graphs and charts simple so they can accomplish their purpose. The only reason you make graphs and charts is to accurately display something. In this case, an athlete's performance. I don't care if it's 3. I don't want it to be 3D. I don't want to look at your graph and your chart and be confused as to what percent you're talking about because you made a 3-dimensional house graph or something. I just made like random stuff to just blow my mind. I don't want my mind blown. Alright? I want simple. That's what math is. We like math to be simple. That's why we simplify things. Alright? That makes sense. Now, last little bit of review before you take this quiz. See that right there? Performance equals ability plus random chance. Who wants to bet me that that's not on your quiz? What does that mean? Who wants to? I'll bet someone that this is. I'll bet someone $8 billion that this is on your quiz. Okay. So I bet $9 million. I bet you. I'll bet you $10 someone gets it wrong. I'm getting wrong. I bet you. Look at you going notes. Nope. Okay, you guys ready? You guys are about to get your quiz. I am going to give you some homework after the quiz. But here, look, I'm telling you. Hold on, buddy. I'll read that.